So now we're going to look at vector operations. We've got, on this lesson, we've got vector addition and scalar multiplication. So vectors are used for a lot of really cool stuff. Here we've got a picture of a plane, an airplane going through the air traveling somewhere. And vectors can be used to look at the speed of the plane and the speed of or the velocity of the plane and the velocity of the wind per se. So say you've got a plane going one way and you've got the wind that's coming the other way against the plane, then your resultant vector is going to be that velocity of the plane with that negative velocity of the wind going against it. Or you could have the wind going with the plane, and then you'd just be adding the vectors and you'd be making the plane go faster. You can also see a lot of these examples with boats in the water and stuff too. So we're looking at a current on a boat or something like that. And this doesn't only go forward and back, it also comes in from the sides and at the angles, and angles will be covered in another lesson, but some neat applications of those. Okay, so vector addition is pretty basic. We've got our vector, which we'll call u, and our vector v, and we're going to give the components of u, we'll just call them u1 and u2, and v is going to be v1 and v2. So adding vectors u and v, we're just going to add up the corresponding components of each. So we're going to take u1 and v1 and add those together, and u2 and v2, we're going to add those together, and that's going to be our new vector, or our resultant vector. Down here we've got scalar multiplication. We'll have our scalar k, that's just going to be any real number, and times our vector u. So we've got k times the components of u, and we can just distribute that real number k into that vector. So we've got k times u1 and k times u2. That's going to become the new vector. Alright, so another way to look at this is geometrically. If we've got u plus v, sometimes you want to just be able to visualize what's really going on here. So if we have a vector u plus v that are in different directions, then we're going to join even if it's in the same direction, we're going to join the initial point of the second vector v with the terminal point of the first vector u. So as you see, the initial point for v is right here at the terminal point of u. And we're going to put them together, and then with the parallelogram law tells us that when these vectors join together like this, and you can either join them this way, it's you could also put v first and then u. It really doesn't matter. But the diagonal from the starting point to the ending point, u plus v, is our resultant vector, and that's what we're going to get when we add u and v. Over here I've just illustrated some different lengths of u when you multiply by a scalar called k, or which we'll call k. So here, notice this is the same length. This u over here is the same length of this u, but I put this one in red just to show that it's negative and it's pointing the opposite direction. So it's u, it's like 1 times u, this is 1 times u, but this is negative u because it's going in the opposite direction. And here's the regular u. I just wanted to put those next to each other for comparison. And here is 2u. As you notice, it's twice the length of both of these actually. And so our k value here would just be 2. 2 is our scalar. And here we've got 1/2 times u, and that's simply just half the length of that vector right there. And you may have already noticed, but k is, when you add k, it's simply a stretch or a shrink by a factor of the absolute value of k.